Welcome to the session on trigonometric ratios, the cosine rule. The objectives for this session are to apply the cosine rule to find a missing side or angle. Before we examine the cosine rule, let's take a quick look at Pythagoras' theorem again, as this will help us to prove the cosine rule. In Pythagoras' theorem, consider a right-angled triangle. The side opposite the right angle is the hypotenuse. Let's denote the length of the hypotenuse by C, and the length of the other sides by A and by B. Then A squared plus B squared equals C squared. Let's take a look at an example. We can apply Pythagoras' theorem to the example on your screen to find the missing side. Notice that A equals 3 and B equals 4. So if we square A, which is 3 squared, and square B, which is 4 squared, and add them together, we should get the length of the third side squared. So since 3 squared plus 4 squared equals 5 squared, we have that the length of the third side is 5. Let's now take a look at trigonometric ratios. In a right-angled triangle, three trigonometric functions are sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. And now for the cosine rule. The cosine rule can be used to find a missing side of a triangle if you know two sides and the angle in between. So considering the diagram on your screen, we have that A squared equals B squared plus C squared minus 2BC cos A. In the diagram, ensure that each side has the same letter as the angle opposite. So little a is opposite capital A, the angle, and little b is opposite the angle capital B, and little c is opposite the angle capital C. We are now going to proceed to prove the cosine rule. Consider the triangle on the right-hand side of your screen. First, drop a perpendicular from C to AB, as shown. We call AX little x, and therefore XB is equal to C minus X, as shown. We're going to use standard trigonometric rules to prove the cosine rule. First, begin with Pythagoras. In this triangle, we have that h squared plus x squared equals b squared. As shown. And in this triangle highlighted, we have h squared plus c minus x all squared equals a squared. If we take one equation from the other as shown, we have x squared minus c minus x all squared equals b squared minus a squared. So tidying up and rearranging gives us 2cx minus c squared equals b squared minus a squared. And rearranging gives a squared equals b squared plus c squared minus 2cx. However, we have that x is equal to b cos A. Using the formula cos A equals adjacent over hypotenuse in a right-angled triangle. And therefore, if we substitute, we obtain the formula shown. And this gives us the cosine rule as shown at the bottom of your screen. So now let's rearrange the cosine rule. The cosine rule states a squared equals b squared plus c squared minus 2bc cos a. To find an angle given the sides, rearrange the formula. As shown. And then subtract a squared from both sides. And finally divide by 2bc. So the cosine rule to find an angle given the sides is given by cos A equals b squared plus c squared minus a squared all over 2bc. And here we have both the formulas. Let's take a look at an example. Find the length of the missing side in example 1. As we're looking for a missing side and we have an angle, we're going to use the highlighted formula. Let's solve this. Applying the formula and plugging in the values, here we have b equals 6.5, here c equals 8.4, and here angle A equal to 20. Calculating gives us 42.25 plus 70.56 minus 109.2 times 0.93969 to give us that a squared equals 10.19585. And therefore square rooting gives us that a is equal to 3.2 centimeters to 1 decimal place. Now let's take a look at example 2. We are required to find the size of the missing angle in the diagram shown in example 2. We're going to use the highlighted formula. So let's find the value of the missing angle and plug in the values of A, B and C. Here we have B equals 4, C equals 8 and A equals 10, giving us that cos A equals minus 0.3125. And therefore A is equal to 108 degrees. Now let's take a look at another example. In triangle ABC, the length of AB is equal to x minus 3 centimeters, BC is equal to x plus 3 centimeters, and AC equals 8 centimeters. We also have that angle BAC equals 60 degrees. Use the cosine rule to find x. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Let's use the information to produce a sketch. Here's the line AB, which is x minus 3 centimeters long. And here's BC, which is x plus 3 centimeters long. And here's AC, which is 8 centimeters long. We also have that angle BAC equals 60 degrees as shown. Now little a is the length of the side opposite the angle capital A. Little b is the length of the side opposite capital B, and likewise for little c. So let's use the cosine rule. x plus 3 all squared replaces a squared. 8 squared replaces b squared. And 8 replaces b. X minus 3 squared replaces c squared. And x minus 3 replaces c. And cos 60 degrees replaces cos A. Now let's tidy up. We expand the brackets and rearrange. As shown. The x squareds now cancel. And we tidy up. As shown. To give 20x equals 88. And finally, dividing through by 20 gives us x equals 4.4. Now let's have a go at example 4. A boat sails due north for 7 kilometers to B from a point A. It then leaves B, moving on a bearing of 100 degrees for 10 kilometers until arriving at C. Calculate the distance of C from A. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. First, we're going to sketch the diagram. So a boat sails due north for 7 kilometers to B from a point A, as shown. It then leaves B, moving on a bearing of 100 degrees for 10 kilometers until arriving at C. So here we have the boat leaving B on a bearing of 100 degrees for 10 kilometers. We are required to calculate the distance of C from A. So this distance highlighted in red at the bottom of the screen. Now let's label the sides so that we can apply the cosine rule correctly. Here's B as shown. And we're substituting that in the formula. Here's A as shown. And here's C as shown, opposite the angle capital C. And of course, cos B is equal to cos 80 degrees because angles on a straight line add up to 180 degrees. And then calculating gives us 149 minus 140 times 0.17364, which gives us 124.6904. Finally, square rooting gives us that B is equal to 11.2 kilometers to 1 decimal place. This brings us to the end of this session. If you have understood its contents, you should be able to apply the cosine rule to find a missing side or angle. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.